Right, today we're going to look at circular motion in a bit more detail. Now, here's a demonstration. The thing I'm going to move in a circle is one of those. You remember those from chemistry lessons? It's a simple bung, and I've got it on a piece of string. Now I'm going to spin that in a circle like that. And it's moving in a perfect circle. Now, if you remember from the previous video, the thing that's making it move in a circle is a force. And it's called a centripetal force. Okay? Now that centripetal force is always perpendicular to the direction of motion. So at the moment, it's always towards the centre of the circle, which is my fingers, because I'm holding the string. Now the centripetal force in this case is provided by the tension in the string. Okay? And that tension is making it move in a circle. Okay, moving in a nice perfect circle. Now the important thing here is, although the speed of the bung is constant, okay, it's moving at the same value of meters per second, its velocity is changing because the direction is constantly changing. So it's constantly accelerating towards the centre of the circle. Now, there are three factors, three quantities which determine the size of the centripetal force needed to move it in a circle. There are three quantities. Right, here we go. Here's number one. Number one is the speed. Okay. At the moment, it's moving quite slowly. So the centripetal force, have a guess. Is it high or low? Okay, but the centripetal force is low, and I can feel that in the string. The tension is very low. I can hardly feel any tension in my fingers in the string. Now if I want to move it more quickly, let's speed it up. Now I can feel the tension increasing. The centripetal force is now much higher. So a high speed requires a high centripetal force. Okay, so that's number one. The second factor is the radius of the circle. Okay, right. At the moment, the radius of the circle is high. Okay, now let's make the radius of the circle much lower. Now, if I want to move it at the same speed, okay, I feel the tension increase. So, a small radius requires a high centripetal force. Okay, the smaller the radius, the higher the centripetal force needed. So that's number two. Now number three is the mass itself. There we go. I've got a larger mass here on some nice green rope. Okay, now what do you reckon that's going to require? A bigger mass requires a much bigger centripetal force. Now I can feel that the tension in this rope is much higher than it was with the bung. And it becomes really high if I move it at a high speed. But the highest centripetal force of all would be, with a small radius, a large mass, moving at a very high speed. Okay, so there you have it. Circular motion and the centripetal force.